which is we're going to learn about applications of definite integrals in business and economics. We're going to learn to calculate two quantities called consumers surplus and producers surplus. And it would be very easy to memorize the formulas of these two quantities, the consumer surplus and the producer surplus, if you know the geometry of that. So let's just review the demand function and the supply function. The demand function is a function like this. It's a decreasing function. So the way you can memorize it is demand is decreasing. So dd, price is equal dx, d for demand. And remember that demand is decreasing. And how does it work? What's the logic behind that? If you increase the price, the demand goes down. So higher prices, so this is price, yes, and this is the demand. So X represents the number of items of a certain commodity that are demanded per day or per week or per month or per year, whatever the time frame is. So for all these problems, for all these type of functions, the cost function, the revenue function, the profit function, the demand function, the supply function, you should always have in mind that there is some time frame associated to that function. So it doesn't matter. It could be day, could be week, could be hour. But what X represent is the number of commodities demanded within that time frame. So let's say day. So X represents how many items of that produce is demanded per day. Yes. And P represents the price. So if you have higher prices is going to be associated with lower demand. So let's say I have X1 here, which is associated to P1. So high price is associated to associated to a small demand. So demand would be whatever this length is. Yeah. So you're going to have a small demand if the price is high. If the price is low, yes. So assume that the price is P2, then the demand is going to be X2. So lower prices are associated with higher demands. Yes. But what happens is that in the free market, a certain price will be established, which has to do with the supply. So let's say that the established price is P bar. And the established demand corresponding to that P bar is X bar. Then, so this would be the market equilibrium. Then there are some consumers who were willing to pay a higher price. So they were willing to pay, for example, there's a certain number of customers who were willing to pay P1, which is greater than the established price. Those customers, they experience a saving because they were willing to pay a higher price, but now they're paying the equilibrium price. So these consumers, they experience a saving, and the collective saving for all these consumers within that time period, which could be a day or a month or whatever, it is equal to this area here. So if this is the demand function, P equals d of x. And again, don't forget, demand is decreasing. And this is the established price associated to this amount of demand. Then this area would be the consumer's surplus. So if I ask to find this area, the area that is between these two curves, the curve, let's say this is y equals p bar because it's a horizontal line, and the demand curve dx. So you can see that within this range, dx is greater than p bar. So that area would be integral from 0 to x bar, yes, of the function that's on top, which is dx, minus the function that's at the bottom, which is p bar dx. That's actually the formula for consumer surplus. So since p bar is a constant, I can make that formula a little more precise and easier to use. Okay, so that's going to be integral from 0 to x bar of dx minus integral from 0 to p bar of p hat dx. So it's going to be integral from 0 to x bar of dx. But the antiderivative of p bar, since it's a constant, so that's a certain number, like for example 10. The antiderivative of 10 is going to be 10x, right? So if I try to calculate this, I get p bar x from 0 to x bar. So it's going to be p bar x bar minus p bar times 0. This is going to be 0. So it's going to be p bar x bar. So this here is going to be minus p bar x bar. Another way of thinking about it is geometrically. This area the area that I'm trying to figure out is the area below so let's say p bar x bar. This area here would be the area below the dx minus the area of this rectangle here. And the area of this rectangle is, of course, width times length. So the width is p bar and the length is x bar. So I can find the area under dx and above the x-axis, which would be this, minus the area of this rectangle, which is just the product of p bar and x bar. So that's another way of thinking about it. Are we good? Any questions? Okay. So that's how you get this formula. Consumer's surplus. The consumer surplus is given by this formula, which I just showed you geometrically. The other quantity that we're going to learn to calculate is something called the producer's surplus. The supply function is an increasing function. The supply function is function like this. So P is equal S of X. X is the number of commodity, the number of items that are supplied per a certain time frame, day, week, whatever. And P is the price. And there again would be some established price, P bar, and some established amount of supply, X bar. And the logic of this curve is that for higher prices, producers will supply more. So higher prices are associated to bigger X values, and lower prices are associated with the smaller X values. That is, a price is low, then there is less incentive for the producers to produce. So lower prices are going to be associated with smaller values of X. But again, in the free market, there will be some established price and sub-established supply. The producer surplus is this area here. So if I ask you to find the area of the shaded region, what would you do? You would say, okay, this area is going to be the area of this rectangle minus this area, which I can denote with a definite integral. So this area, the shaded area, is going to be the area of this rectangle, which is P bar times X bar, minus the area below this curve, so the area that is not shaded, which is going to be integral from 0 to X bar under the curve Sx dx. That would be producer's surplus, for which we have the formula here. Very good. I do not recommend memorizing the formulas. What I recommend is understanding the geometry of it. So generally, if I put both of these functions on the same curve, the supply is going to be like this, the demand is going to be like this, dx, sx. How do you memorize that? Demand is decreasing. Then you have these two areas. This area here is the consumer surplus, and this area is the producer surplus. So the formula for the consumer surplus is going to be integral from 0 to X bar. So 0 is here. From 0 to X bar below the function dx minus the area of the rectangle, which is P bar times X bar. And the producer surplus is going to be the area of the rectangle, which is P bar X bar, minus integral from 0 to X bar below the supply function. Any questions? Okay, then let's look at this example here. Example 1, the demand function for a certain make of tennis speed bicycle is given by this. So we have the given demand function, where P is the unit price in dollars and S is the quantity demanded in thousands of units. So X is in thousands of units and P is in dollars. The supply function for the same product is given by this other curve. So X bar and P bar are not given, but we know that X bar and P bar is the market equilibrium. So you can get X bar and P bar by finding the point of intersection between the demand function and the supply function. You need to make these two equal. So you need to make S of X equal D of X and solve the equation to find X bar. And then when you have X bar, you can plug in X bar into either of the two functions to get P bar. Where P stands for the unit price in dollars, and X stands for the number of bicycles that the supplier will put on the market. The units are the same, again, unit of thousands. Determine the consumer's surplus and the producer's surplus if the market price and the bicycle is set at the equilibrium price. Okay. So for this problem, first I need to make the two functions, the demand and the supply, equal. That will give me X bar. And when I have X bar, I can plug in X bar into either of the two functions. And that will give me P bar. If I plug in that into the supply function, that will also be P bar. So that's the first step. So you have to make these two equal. That will give you this quadratic equation. You have to bring everything to one side. And then in order to get rid of the decimal point, you can multiply both sides by 10,000. So you get 16x squared plus 200x plus 1,500,000. And then you can factor out 8. You get this, or you can just use the quadratic formula. And if you use the quadratic formula, you're going to get two answers. One is minus 625 over 2, and the other one is 300. The negative answer, you're going to reject, because X bar is the number of items demanded or produced per period. So it cannot be negative. So this one is going to be rejected. That means the demand or the supply is 300. So now that you have the 300, you can plug in 300 into any of these two functions. You can plug it in the demand function or the supply function. And this will give you the equilibrium price. So that way you find both X bar, which turned out to be 300,000 units, and P bar, which is 160. Okay, and then you just plug in values into formulas. For the consumer surplus, it's going to be from 0 to X bar, D of X minus the product of P bar and X bar. And for the producer's surplus, it's going to be X bar, the product of the X bar and the P bar, minus from 0 to X bar, S of X dx. So you calculate these, and that will give you the answer. Okay, so my lecture is over. I was able to only find 2 problems in the web work for that. So that's definitely not enough, but that's a good start. I'm going to give you the rest of the class to work on those problems and other problems if you need to catch up, because today is the deadline for 2 sets. But definitely do these two problems from WebWork, from 6.7. There is this one about finding the consumer surplus, and this one is about the producer's surplus for two certain functions. But again, this would not be enough for you for enough practice. So for this set, you should definitely also look at the exercises in the book, the ones that are listed in the course outline for this set. 6.7, it says number 12, number 1 to 5, number 8, and number 10 to 11. All of these exercises are related to consumer surplus and the producer surplus. This part of section 6.7, the present and the future value of an income stream, is optional. So I'm not covering that. So you don't need to worry about these ones. Yes, but exercises 1 to 5, 8, and 10 and 11. So these exercises are related to consumer surplus and producer surplus. So you can do these one first before coming to WebWork, or you can do the WebWork first and then do these ones. I'm going to put the formulas on the board and then give you some time to work on these two exercises. Any questions? Okay. So you have to make these two functions equal, solve for x bar, and when you have x bar, you plug in x bar into either S or D, and that will give you P bar. Then the consumer surplus is going to be integral from 0 to x bar dx minus P bar x bar, and the producer surplus is going to be P bar x bar, which is going to be the area of that rectangle, minus integral from 0 to x bar of S of x dx. So work on these problems. Let me know if you need help.